Behind every video game, every special effect, every AI, there's a hidden world, a world of numbers, patterns, and elegant equations. Today, we pull back the curtain and reveal the secret language of mathematics. Welcome to the world of matrices. Here's our mission. First, we'll encounter a problem, a real challenge from the gaming world. Then, we'll translate it into the language of matrices. We'll discover a powerful tool called the inverse matrix. We'll master the technique of elimination. And finally, we'll see how this math powers everything around us. Ready? Let's begin. Imagine you're inside a video game, a vast digital universe built entirely from mathematics. Your spaceship fires a laser beam through space. Ahead, an enemy shield blocks your path. The question is, where exactly does the laser hit the shield? To answer this, we need to solve a system of equations, and that's where matrices come in. The laser travels along a line. The shield exists as a plane in 3D space. Where do they meet? This isn't just one equation, it's three equations with three unknowns, x, y, and z. Each equation represents a constraint, and the point where all three are satisfied, that's our answer, the intersection point. X equals 1, y equals 2, z equals 2. Look at these three equations. There's a pattern here. We can extract the coefficients and arrange them into a grid, a matrix. The unknowns become a vector. The constants become another vector. And suddenly, three messy equations become one elegant statement. A times x equals b. This is the power of matrix notation. Compact, beautiful, scalable to any size. We have the equation ax equals b. But how do we find x? We need a key, something that unlocks the solution. That key is the inverse matrix, A inverse. When we multiply A inverse by A, we get the identity matrix. It's like multiplying by 1. So if we multiply both sides by A inverse, the left side becomes just x, and the right side, A inverse times B. That's our solution. X equals A inverse B. But how do we actually find A inverse? We use a technique called Gauss-Jordan elimination. Start with the augmented matrix, A and B side by side. Then, using row operations, transform A into the identity matrix. Multiply a row by a constant. Subtract one row from another. Step by step, the matrix transforms. Zeros appear where we need them. Ones appear on the diagonal. When A becomes the identity, the B column becomes our solution. X equals 1, Y equals 2, Z equals 2. But sometimes things go wrong. What if two equations are actually the same line? Then we have infinite solutions. Every point on that line works. What if two equations are parallel lines? Then there's no solution. They never intersect. These are called singular matrices. The warning sign? A row of zeros where it shouldn't be. When this happens, A inverse doesn't exist. The system is either impossible or has infinitely many answers. Matrices aren't just for solving equations. They transform space itself. The identity matrix leaves everything unchanged. A scaling matrix stretches or shrinks. A rotation matrix spins objects around. A shear matrix creates that italic slant. And when you multiply matrices together, you combine transformations. This is how every 3D game, every animated movie, every virtual world moves and transforms its objects. Matrices are everywhere. In video games, they rotate and position every 3D object. In image processing, small matrices called kernels blur, sharpen, and detect edges. In artificial intelligence, neural networks are essentially chains of matrix multiplications. Weights transforming data, layer after layer. From your phone's camera to self-driving cars, matrices are working behind the scenes. We've seen matrices at work everywhere, but there's still a mystery we haven't explored. What happens when B equals 0? When every constant on the right side vanishes, we call it a homogeneous system. AX equals 0. There's always one obvious answer. X equals 0, the trivial solution. But for singular matrices, something magical happens. non-trivial solutions appear, entire lines or planes of answers, all passing through the origin. This collection of solutions has a name. It's called the null space. The null space reveals what a matrix destroys. It's the set of all vectors that get mapped to zero, inputs that the matrix completely annihilates. For a non-singular matrix, the null space is tiny, just the origin. Nothing interesting escapes. But for singular matrices, the null space expands into a line, a plane, or beyond. The key to understanding this is the rank. Rank counts the number of truly independent equations, the ones that actually constrain your solution. Here's the beautiful part. Rank plus null space dimension always equals the number of variables. 3 variables, rank 2, 1 free dimension. Your solutions form a line. Rank 1, 2 free dimensions, a plane of solutions. This balance is the heartbeat of linear algebra. All this elegance deserves a powerful tool. Enter MATLAB, solving AX equals B, one line, a backslash B. Need the inverse, inv of A. The null space, null of A returns the spanning vectors. The rank, just type rank of A. And for systems with no perfect answer, PNV and the pseudo-inverse finds the best you can get. What once took pages of calculation now takes a single command. Theory meets practice. That's the power of computational mathematics. And so our journey through matrix algebra is complete. We began with a question: where does a laser hit a shield? From that simple puzzle, we discovered a universe. We learned to speak in matrices. A times x equals b. We found the key, the inverse matrix. We mastered elimination, row by row. We faced the edge cases, when solutions vanish or multiply into infinity. We explored the null space and understood the delicate balance of rank. We saw matrices transform space and power the technology all around us, and we put it all into code. But here's the secret. This is only the beginning. Eigenvalues, determinants, vector spaces, singular value decomposition, each one a new door waiting to be opened. Mathematics is not a destination. It's an endless adventure. Keep exploring.